I now take up extensions of L'Hopital's rule. So earlier we talked about an interval alpha beta around A, an open interval alpha beta around A, except possibly at A. And we said that suppose both f of x and g of x tend to 0 as x tends to A. In that case, if g prime x not equal to 0 for all x not equal to A in this interval, and if limit x tending to A f prime x by g prime x is equal to L, then we have this case. What is written here, limit x tending to A f of x by g of x is equal to limit x tending to A f prime x by g prime x is equal to L. Here we talked about an interval alpha beta around A. But what if A is an endpoint of the interval alpha beta? Then wherever I have written x tends to A, and here also I have written x tends to A, that will be replaced by x tending to A plus or x tending to A minus. That means x tending to A from above or x tending to A from below. So that's the first extension. We are actually going to consider 3 extensions of L'Hopital's rule. The first extension is we consider A being an endpoint of the interval alpha beta. Now in this case, x tending to A will be replaced by x tending to A from above or x tending to A from below, as the case may be. That's the first extension of L'Hopital's rule. Let's take up the second extension now. Wherever we have written A, this can also be replaced by infinity or minus infinity. So in this case, if I am writing limit x tending to infinity f prime x by g prime x is equal to L, then limit x tending to infinity f of x by g of x is equal to limit x tending to infinity f prime x by g prime x equal to L. So A can be replaced by infinity or minus infinity. That's the second extension. The third extension is that our L'Hopital's rule also applies to other indeterminate forms. Till now, we have considered the indeterminate form of type 0 by 0. The extension tells us that the rule in fact also applies to other indeterminate forms such as plus infinity, in fact I should say plus minus infinity by plus minus infinity. So the rule also applies to other indeterminate forms such as plus minus infinity divided by plus minus infinity. Again, this is an indeterminate form. I'll write it in this way. Let's understand these extensions with the help of a question. Let's suppose we have to find this limit L, which is limit x tending to infinity, fifth root of x raised to the power 5 minus x raised to the power 4 minus x. So I want to find out L in this case. The way to proceed is to first pick up this one, this expression, and see what it is equal to. Let's try to simplify this expression separately. So I write this expression here, fifth root of x raised to the power 5 minus x raised to the power 4 minus x. This can be written as x raised to the power 5 minus x raised to the power 4 raised to the power 1 by 5 minus x. Now what I do is I take out x raised to the power 5, and the trick is to understand that we are concerned about limit x tending to infinity. So the best way to approach this is to think of the highest degree of x and take that out as a factor. So we take up x raised to the power 5, write 1 minus 1 by x, and this thing raised to the power 1 by 5 minus x. This can be written as x raised to the power 5 raised to the power 1 by 5, which is just x, and then I can write 1 minus 1 by x raised to the power 1 by 5 minus x. Now this expression can actually be written this way: equal to x 1 minus x raised to the power 1 by 5 minus x divided by 1. The same expression, just that I have divided it by 1, so nothing changes. Now what I do is, since x tends to infinity, so obviously it's clearly not equal to 0, so I can divide both numerator and denominator by x now, and that means I can write it this way: 1 minus x raised to the power 1 by 5 minus 1 divided by 1 by x. So this expression, this one, is in fact equal to this expression. So now I can write my L to be this. L is equal to limit x tending to infinity, but now instead of this expression what I have written here in the beginning, I write this expression, and so I can write 1 minus 1 by x raised to the power 1 by 5 minus 1 divided by 1 by x. And now you can see that both the numerator and the denominator, both of them separately, they tend to 0 as x tends to infinity. So this limit, what we have here, is an indeterminate form of type 0 by 0. I'm just trying to apply the extensions. We have a being replaced by infinity here. So I write it like this: equal to limit x tending to infinity. This can be written as 1 by 5, 1 minus 1 by x raised to the power minus 4 by 5, and then 1 by x squared. This is equal to minus 1 by, so now divided by minus 1 by x squared. This is, and here I can see that I can, okay, now in this case let's try to write it this way, and so we can cancel out these two, and now I can write this to be equal to limit x tending to infinity minus 1 by 5, 1 minus x raised to the power minus 4 by 5, which is nothing but minus 1 by 5.